Ladies and gentlemen, welcome to this last session of the day. This is about Service Bus. Some of you may have already heard of that product. Some of you may not have heard of that product. We're in Windows Azure. We also have a server product. And in the next 75 minutes, I will tell you all about it on just 62 slides. But including this one and the previous one, so don't worry too much about it. We're down to just under 60. So the topic of the day is building scalable, robust apps, and that's also my excuse for not showing you any demos, because the point is you can't build large and scalable, robust apps in 5 minutes. Therefore, I'm going to be showing you some code, but I will not be sitting here live coding, pretending I could build a large and scalable thing in that short period of time. But I'm going to talk to you about components that we have in Service Bus specifically that will help you with building those kinds of systems and how we interact with components that you might know, for instance, from the web. For instance, a wonderful technology that we have brand new out in version 1.0 named SignalR. So I'll be covering that as well. Myself, Clemens Fastas, I work on the Service Bus team, or also mobile services team in the Windows Azure application platform team. In Redmond, my team is in Redmond. I live just across the border in Germany, close to Mönchengladbach, where your best Belgian players, football players play, usually. And with that, let's get going. Service Bus is a middleware for messaging and has a fairly broad scope, and that scope is expanding. So we go from effectively from appliances, from embedded devices, down to enterprise systems. And we interconnect things with a number of entities, as we call them, things that you can put into Service Bus to interconnect things. So there are queues, there are topics for publish and subscribe, we have relays, and we have notification hubs, and I'm going to talk about all those during the session. So to give you a definition, what is Service Bus? Service Bus is two things, really. It's a cloud-hosted infrastructure, and it's also a self-hosted infrastructure. So a subset of the features that I'm talking about today, you can go and download right now, if you wanted to, from download.microsoft.com, called Service Bus 1.0 for Windows Server, and that gives you the same messaging engine that we have in the cloud, also for your own data centers and for your own setups. We also, as a team, own the Microsoft Message Queue, MSMQ, so this is interesting. The successor technology, really, of the Microsoft Message Queue. Even though it is slightly different, and I'm going to talk about that also as I speak about server in more detail. So the key features of Service Bus overall is pub/sub reliable messaging, the relay, and notifications. The customer scenarios, that's what I want to lead with, that we see people using Service Bus for, is for instance, first, building cloud services. So we are part of the Windows Azure platform. We're available as a platform as a service component, which means we run Service Bus for you. We run for you clouds as queues and topics and those relays and those notification hubs, and the way you create them and maintain them is by simply going create one in the portal or create one in the API, and then we take care of them for you, and you get full 24/7 support for those if there are, and you get an SLA of 99.9% on reliability. So you can go and build cloud solutions for them, and you can base your cloud solutions on them. Then we see hybrid configurations where you have parts of your applications on premises and parts of your applications in the cloud, or where you have multiple sites across the world that you need to go and synchronize and need to send messages across. Well, we give you a capability, because we're sitting with Service Bus in the cloud, that doesn't require you to build VPNs, that doesn't require you to do any other stunts about connectivity between sites, but you can actually go to a place, and in that place you can post messages, and you can also get messages, and that's a reliable transfer mechanism that we have there. Or also using the relay. And then we have a number of scenarios around connected clients where really the clients are being connected to Service Bus, and Service Bus plays the role of a gateway for your applications. There's a number of different kinds of scenarios, and I have some examples here for you. The first one is Halo 4 by 343 Industries. 343 Industries is a game studio owned by Microsoft. It's in the Puget Sound area, and they're producing the game Halo, which you might know. And if you don't know it, your kids might know it. Halo is a first-person shooter. It's mostly about killing people, monsters, and also other Spartans. And so as you play this in the multiplayer mode, the Xboxes form a peer-to-peer mesh, effectively, and that's how you play. But you collect you collect stats. You collect points, headshots, kills, etc., etc. And for people who are playing Halo, their statistics, their career as a Spartan is very important. It's arguably as important as business transactions are for other people. So people are really keen on their career in Halo. And Halo has a thing called Waypoint, which you can load onto your iPad or on your Windows phone or onto your Windows 8, which kind of gives you a companion view of your career in Halo. So as the game goes on, and you can join a game or leave a game, there's slots kind of on the devices, on the Xbox devices, which kind of collect those stats. As you are in the middle of a game and someone joins and one of those slots get full, they now need to go and bleed those stat slots off to a central service. So they post this to a gateway role that's sitting at the edge of the Xbox Live network, which you can imagine as being something like IPsec, over the public internet. And that will then, the gateway actually post this then to Service Bus queues, and those then go to the backend role. The Halo backend is then turning that, kind of aggregating all this information, and then posting that so that the Waypoint application can deal with that. The interesting thing here in Halo is the load, and also the spike, the load that they see generally in terms of spikes. They have spikes throughout the day. When people tend to be off work, it spikes up, and then it spikes further down. It's a global thing, so actually those spikes roll through different data centers. What's also interesting is the adoption curve. If you and me are writing a web service, the adoption curve is something like this, right? You start slow, and if you're successful, you're having more users. Halo sells box copies, right, on the open market. They roll them into retail stores, and they sell millions of these on the first day, which means they have millions of users on the first day, which means their adoption curve looks like this. It starts there and then starts gliding off, which means they need to be ready on the first day. So that's what they put queues in the middle to deal with that, and they actually had some back-end issues during the first 2 days, but they lost no data because the data went to Service Bus. Retail services, completely different story, clearly not game-related, also lower scale, but higher need for reliability. So there's a point of sale, and the point of sale is collecting stats about what they've sold so that they can go and get this out to the inventory services in the warehouses so they can go and resupply the stores. Also, a way to go and post some data. This goes into retail web services for analysis, etc. And also a way for marketing and also for the administrators to go and post data back to the point of sale. The terminal, so we're talking, for instance, about high-end retail stores for fashion here. So the retail stores have machines that are sitting in these in the stores, and now they change prices. They have a central marketing campaign going on, and they say, we're now selling this piece of clothing for only 599 euros. The price is controlled from that central marketing organization, right? The stores don't control that. So how do you distribute that pricing information? in near real time? Well, you post that into Service Bus, and then Service Bus goes and does the distribution for that. Also, how do you flow that data in from point of sale? Also through Service Bus. And there's no connectivity issues because we're sitting out in the sky and are controlling that reliable flow. Any of those systems can be offline at any point in time, unavailable, the store closes, the machine gets shut down. Well, when the machine comes back up, the data is there for it to read because we keep that data as messages in Service Bus. Enterprise Services ISV, you have a private cloud, and then you have another enterprise private cloud, and you just have completely private systems. But you want to go and selectively take capabilities you have in these systems and bridge them across and make them accessible. One example for that we have, actually more in a, we have this model. You have a private cloud that's being set up somewhere, a dedicated solution that you install somewhere that sits in some cloud system, and you want to go and take a web service of that and make it expose it so that another ISV can use it. Another variant of that model is we have, for instance, with EasyJet, friends who have been with us since Service Bus exists, and they take their internal booking systems and project them out to the cloud so that mobile devices that they run can actually get to those services. So they expose them out through the relay. And then CRM Online is going to use us for push notification services, where all these different clients are talking to CRM Online, and if there's anything happening on the back end that needs to be alerted to the user, a new lead, new contact, something changed that's relevant to the user, that is all rules-based, then they can use our new features, the notification hubs, to actually do targeted notifications for individual employees, or they can go and just broadcast out to the entire sales staff if that needs to be. So CRM Online is going to use us for notifications along with another set of internal properties inside of Microsoft. And we have a lot of external users, and based on what I know in terms of customers that we have, it's very likely that you personally are going to use our notification services in some form yourself on your phone without knowing in early next year. So let's talk about the capabilities. Let me do a time check here. Let's go through the capabilities that we have one by one. Again, I'm going to stay with these features which have been around for a while, a little above the, a little abstract. If you need actually deep walkthroughs, you can go to my blog on Channel 9, blogs, subscribe, channel9.mcn.com, all the things. If you have something that you're really interested in more depth, you can go there tonight and go and find a clip there that's actually relevant to you, how to use the relay, etc. You can go into depth on that subscribe blog, which has a ton of video content on details of Service Bus that complements this talk. So the relay is a way to go and expose web services from anywhere to anywhere. We have a relayed unicast and multicast. It's kind of, you think about the multicast capabilities as a fairly constrained, similar way of doing what you can do with UDP. You can sign up to the same address, and then you get the data that's being posted to that address. And the way this works is that you have you have services that you built today on WCF and either on NetTCP or on plain HTTP, in the very near future also on Web API, so we're extending the reach of the relay also to Web API. And we have something that's planned, what we call the IIS Hybrid Cloud Bridge, which is an extension to IIS, which you basically just configure, and then anything that sits behind IIS, may that be PHP, or may that be Node, or may it be anything, can then be exposed through the relay, made accessible to the rest of the world from any machine that can see the internet. The way this works is that we take your web service, let's take here this WCF NetTCP service, and instead of this opening a listener locally, what this will do is it will open up a connection. As it starts up, we'll open up an outbound connection to Service Bus, and we'll register a name on Service Bus. As it does that, it reserves a name. It also gets an effectively publicly accessible address. And then if you have a client that comes to us, we play the gateway, we take that traffic and send that down that open socket so that you can go and receive that. So if you built WCF services today, you are set. You can go and use this today as a capability very easily. If you build web API services, you will be able to use that very soon. That's the first capability that we shipped. This is in production since January 2010. Programming model is based on WCF. So if you're using the Windows Communication Foundation today, in any of these bindings, those bindings are available effectively symmetrically. So you can, if you have something that's using, let's say, the web HTTP binding, you can replace that with the web HTTP relay binding and then make your service just work. So sorry for making that section a little terse, but we have a lot of material to go through. Messaging. Messaging is about asynchronous messaging, where you give us a message and we go and store that message somewhere and then distribute it further. There's two big entities that we have there. The previous one was the relay. Here we have, in this section, we have two. We have queues and we have topics. A queue is an ordered message log. So it's a sequence of messages that we maintain for you. And we do a number of things like basic housekeeping things for you, which are already useful. First of all, we give you a strictly monotonic sequence number that we stamp on those messages, which means you get a strictly monotonic sequence, an order of arrival. We also give you an authoritative clock. You give us the message, and we tell you exactly when that message arrived. So if you are building an auctioning system and you have any doubt about when that message arrived, well, you can actually read it on the message with NQ time UTC. We store the data in SQL, which is an interesting detail for when you think about the Service Bus server. And so we are as reliable on the storage side as you make your SQL server if you're hosting it on server. Once we give back, yes, we have the message, it's stored on SQL. In the current mode, which is always stored and always reliable, there's a mode in the works. It's going to definitely ship this year, which we call the Express mode, which is going to bypass the reliability so we can actually go and lower the reliability and actually get significantly higher throughput out of the system. You can also multiplex for those queues using sessions, which is one of the more advanced features that we have. Two basic modes. The standard mode of a queue is to pull messages from it. You send messages, and then you say receive, and then you can go and load balance based on that. We also have a model for forwarding, which I'm going to talk about in more detail later with some extra slides. A topic is exactly like a queue, but it's giving you multiple outs. So you post messages in, and now you have effectively if you have three subscriptions, you have three virtual cursors, if you will, that go over that sequence, and they're independent, they're named, they're durable, so you create one, it lasts, you can come back to it and get the next message, or even after days. But you can also set an expiration date for them. That's a new feature. Currently available in preview, in production very soon, or in production client very soon, where you can basically say, this subscription is going to last only 5 minutes when it's idle, and then it goes away. So automatic cleanup effectively. And then there's rules for filtering what messages you're going to get out of this, for which I also have an extra slide. The programming model options for the messaging model are very plentiful, as you can see. So let's go through some of them. So you have Service Bus and you have your app, and your app might be written in all kinds of different languages: C, C++, Java, Python, PHP, Node, or any HTTP client. On the Windows side, it might be written in WCF, might currently be using the MSMQ binding in WCF, if you heard of that. So we have the equivalent there in net message binding, and then we have the .NET Service Bus messaging API. The few snippets of code that I'm going to show here are going to use that API. All those clients have coverage today for Service Bus. So in the Python SDK, PHP SDK, Node SDK for Windows Azure, you're going to find HTTP clients. These Python and PHP clients are going to move to Apache to bind to Apache Proton-C. So Proton-C is a AMQP library that's being implemented by Apache. I'm going to talk about AMQP in a moment, what that's for. But the goal is that we effectively move all clients away from our current proprietary protocol, the Service Bus messaging protocol we currently use for the most advanced features, completely to AMQP 1.0 and to HTTP, so that we have two completely open protocols and you can come with any client. The goal for us is here to have a universal messaging fabric in the cloud as in the server, where you can post a message through HTTP and you can pick it up through AMQP or vice versa. So the connectivity options that exist today for the cloud are the following. AMQP 1.0, I'll talk about that more in detail. With AMQP-S, that's the SSL standard version on port 5671. That needs to be open from your site wherever you are, outbound only. There's no inbound connectivity required for any of the Service Bus features, but it needs to be available outbound as a port. And you can, if you want to, you can constrain it to the Windows Azure data centers. That is, however, not a good idea, because there's a lot of stuff in the Windows Azure data centers. So instead, if you're creating firewall rules for these things, constrain the machines which are sending, right? Make the firewall rule inbound. Say, this group of machines can get through the firewall on the following port, outbound, if you are in a restricted environment. Don't make it a matter of the target machines, but trust the source machines. Just that as an A-side. The SBMP, Service Bus Messaging Protocol, sits on port 9354. The relay sits on 9350 through 9353. And then HTTPS obviously uses TCP 443. So if you want to use AMQP, because we also require tokens from the access control service, potentially you will need 443 and 5671 for outbound connectivity. No inbound connectivity needed, so none of these federated sites, which you might be federating, for instance, the point of sale here, none of those need to have open inbound ports of any sort, no VPN setup. You basically just need to have outbound connectivity. AMQP 1.0 is an effort that we have started supporting several years ago, and it's an effort supported by over 20 companies. It was actually started on Wall Street by a number of customers, namely JP Morgan Chase and Bank of America, joined by some other customers as well. This is kind of falling apart on me. And then there's a number of technology vendors who are also in there and have compatible implementations. We're one of them. So this has been announced as a ratified standard by OASIS, AMQP 1.0, and now is on track to ISO standardization. The goal is that we have finally a reliable messaging protocol that's interoperable, which is better ultimately than HTTP, and I'm going to get to that as well. Better than HTTP for the use case. So open standard, reliable, flexible, and broker model independent, which is also very important. So let's talk about those things a little more detailed. First of all, the goal is that in AMQP is to have a very simple abstraction for all messaging patterns, so that we can do point-to-point. We can take a server and a client and directly connect them and have a way to have a reliable handoff of messages between them, which you can't do with HTTP. Right? HTTP doesn't give you the reliability for a reliability handshake for whether you got the message and whether you got the reply. So it's making a reliable and a simple abstraction, but for a reliable handoff. It's a peer-to-peer protocol, and then it has mappings to standard APIs. So we are on the hook to provide one for .cf because, interestingly enough, the non.net world cares about us having that for .cf, so we're going to do that eventually. But our first implementation is obviously going to be through the Service Bus API for JMS, and also a mapping for how to send SOAP messages through it. And it's designed for high performance, high throughput, which also means that it's completely binary. So it's not sending any XML, it's not sending any JSON, it has its own binary encoding for the purpose of being fast. And we have AMQP implementations internally, peer-to-peer, that can actually go and easily saturate a gigabit network. It supports at most ones, at least once, exactly once delivery, has recovery well-defined for all the cases when anything can go wrong, and a well-defined error model. And it defines a basic model for messaging, but it's not particular to a broker. It's actually also enabling brokerless messaging. So it says make a link, make a session, things like this. It also has a notion of sending a message and handing a message off, but it's not saying, do this on the queue or do this on a particular topic. So it doesn't have a notion of subscriptions. It doesn't have a notion of queues. It doesn't have any notion of that. Those are vocabularies which can be built on top of AMQP very easily, but they're not built into that model. So it's a peer-to-peer binary duplex protocol that has been negotiated and agreed upon by a large number of companies, which is actually a first in that space. So we could demonstrate interoperability if this was just an AMQP talk, then I would actually do that. But we are, as you've seen in my list, Cupid, an Apache effort, is something that we're actively supporting, and we're going to go and ship clients using that as Microsoft, using that Apache library to customers because they're good, and we're actually working with customers already. The Proton C library is actually built specifically so it's small and works on embedded devices because we're hoping that people will actually use Service Bus also for embedded device scenarios. ActiveMQ is using that as well. And then there's VMware, there's SwiftMQ, there's Red Hat and INETCO, and a number of other vendors who are building broker products which are going to support AMQP 1.0. And our goal is complete interoperability and exchangeability of those brokers, which is not given with all messaging products on the market, including the leading one. Service Bus supports AMQP 1.0 in preview today, so you can go and take a look at the documentation that we have on MSDN. It actually tells you how to set up a JMS client. You can use standard JMS commands. We're using actually the JMS binding from Apache, and you can use that against Service Bus. And if you want to use AMQP from .NET, you can do that too. Eventually, you're going to use it automatically because we're going to switch to AMQP as soon as we fit all the features. If you want to use that today against AMQP, also for using the Service Bus libraries against some other AMQP brokers, that's another function of them, you can go and get the servicebus.preview assembly from NuGet. This is going to be a standard released feature very soon in Service Bus. We're saying here general availability in the first half of 2013, and that has not changed. We're still committed to do that. So that was AMQP. In general, the message model for Service Bus, irrespective of how you post messages to us, is the same. So whether you use HTTP, whether you use AMQP, whether you use one of our APIs in various forms, the message model is always the same. The message model is a set of system properties that you can use to go and control how Service Bus behaves, a set of custom properties, key value pairs that we accept as part of the message. Think of those as headers, but they're not SOAP headers. They're just part of the message. Think of them more as HTTP headers. Things that are flowing extra HTTP headers that have no semantics. And in fact, the way how we map our HTTP protocol is exactly like that. All the system things that are meaningful on the wire, right? They are system properties, and there's actually a special header we call broker properties. That's a JSON serialized array where all the system properties go, and then everything else is posted as normal headers in HTTP and also comes back as normal headers in HTTP. You can, with Service Bus, posting a message, you don't even have to send an entity body. That's the body here. The body is just a bag of bytes, and you don't have to post that. The limits here are 256K per message and 64K maximum for all these headers together. If you have messages that are larger than that, there's multiple ways of doing that. You can create a session, And with the session, we give you exactly in order delivery semantics over a sequence of messages, and you can actually go and multiplex them through. I have a sample where I can go and take an entire directory of images and flow those through. I'm not completely done with that yet, but I'm going to post that on, I'm going to explain sessions probably sometime next week on the Subscribe blog. So you're going to see that sample there, and you can also get the code. So if you want to have large transfers, you can also go and do that using those sessions. So don't be too worried about that maximum message size. And the reason why we have that maximum message size is because otherwise we can't just can't make the system scale. Very easy. If we have to haul around bigger blocks of data, we can't make the system scale at the scale that we're running. The delivery options on the messaging is receive and delete, get a message and delete it once you get it, which means if you crash once you have the message, then the message is gone. Peak lock is the other model where you have you take the message, you get it locked exclusively to you with a time bomb that's configurable, and it's also renewable. So 2 minutes, 5 minutes, and then you can renew another 5 minutes while you have time to process that message. And once you're done with that message, you tell us, I can delete it, or you return the message to us and we deliver that to someone else. There's automatic poison control, so if we deliver a message to you and that makes you crash repeatedly, we're also going to put that on the side and we're going to dead letter it, as we call it. If we use sessions with peak lock, that will give you absolute order guarantee, so you're not only locking a message, but you're locking that message and all messages that are behind it that carry the same session ID if you turn on that feature. The two kinds of receive operations that we support depending on protocol. There's a credit-based model that we use for the binary protocols, where you can, because the connections are multiplexed and they support bidirectional flow, completely independent of other operations, you can register 100 receive operations from 100 different threads over that same connection, and then can get them serviced, and also on different entities, and can get them serviced completely out of order or independently. As a credit-based model, we register 100 credits, and then we service those 100 credits on that link. In HTTP, we have a long polling model where you walk up to one queue and you ask for one message. That works wonderfully, but it's not as efficient as using any of those binary protocols. I'll also have a slide for that later. Price usually comes at the end. I'm doing that in the middle so that you know what this is about. $1 per 1 million message transactions, $1 or 1 cent per 10,000 message transactions. Sending a message up to 64K costs you one of those transactions. Getting a message up to 64K costs you another one of those transactions. Each extra 64K segment also costs you one of those transactions. If you do the math on that, it's for a reliable messaging system, it is actually remarkably cheap. You can't buy the machine to run this on plus the Windows Server license for a long time if you're using that with that price model. The long polling operations in HTTP, every time the maximum we can allow you to long poll is 60 seconds because the intermediaries will cut you off. The Windows Azure load balancer is going to cut you off. Your own proxies or NATs are going to cut you off. So we need to remind the infrastructure every 60 seconds. So the longest long poll that's practical is 60 seconds. Every time we can't give you a message because you have a parked request and don't have a message for you, also costs you one of those messaging transactions. However, that's very different to the storage model that doesn't have that long polling thing. We're actually pushing you towards a model where you park the sockets with us. Outbound Windows Azure surcharges only apply if the traffic actually leaves the Windows Azure data center in these hybrid scenarios. If you're in the data center, you don't have to think about that. But they're also relatively cheap and they're in the cents range per gigabyte. So, that all said, as a general overview of the messaging capabilities, let's talk about Service Bus 1.0 for Windows Server briefly, and what that animal is. So, as I said, you can download this. So, on download.microsoft.com, or this is not stable. On download.microsoft.com, you can easily go and get that one. And what that gives you is first of all, on-premises pub sub. You don't have that with MSMQ. You can get that from other products, but the way you get this from Microsoft today is using the successor technology of MSMQ called Service Bus for Windows Server. On-premise pops up infrastructure that you can go and host yourself, has the same features largely as the ones that we give you in the cloud. Also, if you want to develop applications for the cloud on premises alongside with the Windows Azure emulator, well, with that, you now have an option to use Service Bus completely on premises, at least the messaging capabilities, and kind of use that as the emulator, even though it's a full-fledged server. And also, obviously, have a deployment flexibility where you can go and deploy the server version, and you can also have that then run in the cloud, so you have deployment flexibility. And you can also do tiered deployment where you maintain the Service Bus on both ends and kind of replicate between them. You have a Service Bus on premises, you have a Service Bus in the cloud, and you post to, let's say, an outbound queue, and that outbound queue then pumps the data out to the Service Bus in the cloud. We don't have that automated yet. You have to actually run and host that little pump, but we're going to get that automated, I hope, until the end of the year. The way this works is you have you're setting up yourself, if you're downloading Windows Server, you can set yourself anything up from a dev machine to a full cluster. The nodes are completely identical, and so we implement full failover. What we give you in the cloud, a full failover model, is also what we give you here. There's a fabric that backs all those things up, and the ownership of queues is managed by that fabric. And so you get the power of 3 machines, but if you go and pull the plug on any of those machines, those queues which are managed by that machine that's now missing gets automatically rebalanced to the other servers. You don't have to worry about that at all. Literally, if you have 3 machines which are sitting side by side kind of in a rack, you can go and take one of those machines and pull it out, and it will work. So that's the cluster capability that we give you for free. Just join them together in a single deployment. What you also notice this is very different from MSMQ. MSMQ is a peer-to-peer queuing system with a central registration in Active Directory, where data gets transferred between those peer-to-peer queues. This is a server. So if you need to have local capabilities, if you need to have a local queue that you can go and queue things into, you can still use MSMQ and go and then replicate that data out. And also, we have samples around how to do this. We own MSMQ. It's in every copy of Windows. So you will see us leverage MSMQ for that bridgehead function because it's there. So if you need to have a client machine that goes and replicates data out, but it's not always connected, then you can have a local bridgehead for that. But Service Bus is a server product that you run on the server. It's supported only for Windows Server 2012 and for Windows, let's go here, Windows Server 2008 R2 SP1 and Windows Server 2012. And then there's a DevBox scenario, which we have enabled, so you can go and develop yourself, but there's no official support for that. So official support only is on the server versions. We run completely on top of SQL Server Express. If you want to do that, we also run up to the highest clustering configurations of SQL Server proper. How reliable you want your data to be depends on how you deploy SQL Server in the end. So we're effectively saying you can get all the capabilities of SQL Server, how to manage your data. We're gonna use that, and we're going to leverage to the max. So if you are putting your SQL Server Express on a single disk without any replication, and that disk goes away, well, that's bad luck. If you will put this into a SQL Server 2012 shared nothing cluster like SQL Azure, well, that's probably a good idea. Perf, we haven't talked about those numbers yet. This is not a guarantee, this is what we measured. Right? That's what we measure in our test rig. So that's a set of results. 3-node farm plus 1 SQL server, all 4-way quad-core CPUs with 24 gigs. The SQL server was equipped with 6 disks, but it's 1 SQL server. Our test messages are always 1K in payload, and so we can go and pump 20,000 messages per second on one entity on one queue, so 40,000 operations per second on that thing, and it's all saved, reliable, transactional. We're expecting much higher rates as we go express. That is, even if you look across the competition, not shabby numbers. Single topic with one subscription, because of some more mechanics, 14,200 messages per second. And single topic with 1,000 subscriptions, because now you make 1,000 copies of each message, all right? 26 messages flow rate. When I say flow rate, I mean how many messages do you see on the other side on each individual receiver flow rate per second. You can make this broader. You can actually get more messages if you go and combine some things, as I'm going to show you in a moment. And by the way, the bottleneck here is clearly disk I/O. So if you make the disk faster, this is on spindles. So if you were running this on SSDs, you're probably going to get faster. This is all I/O bound in the end. Messaging patterns. What do you do with it? Well, first of all, broker transfer. If you have a queue, that gives you a number of good capabilities. It gives you load leveling. Someone can push against you really hard, and the receiver goes and gets data at their own leisure. And typically, pushing really hard happens in spurts. So you get the data pushed against you, but you have as much capacity on the back end as you really need for timely processing of that data, which is not always the case. So you can go and do that leisurely. You can observe the queue length. If the queue gets long, you can add a receiver. If the queue gets short, you can drop a receiver. Also, when the receiver is offline, taken offline for servicing, we're still taking the data into service bus and then hand it to you when the receiver comes back online. Or you might do that intentionally by just bringing up a service once a day, once an hour, to go and get the data in and process that data from a batch. A load balancing, you get very naturally, already mentioned that. If you have multiple receivers which are concurrently pulling in competition from that one queue, you get actual load balancing, not the load balancing in the form of I spray traffic to you, but only I get a message, I work on that. Now I'm not getting new messages. And then once I'm done with my job, I'm getting the next message. So it's actually load sensitive because you're pulling. You can have fan in, where you have a number of senders that go and send into a queue to a receiver as a concentrator pattern. I'm going to go and talk about that also in more detail when I get to composition. And then you can go and actually do this in steps where you have a receiver. The receiver takes messages, rolls them up, and then posts them further into the next queue. And we can actually go and lay transactions around those things so you can make that a transactional operation so that the messages you are taking out of one queue don't get lost if sending to the other queue doesn't work. So we can actually bundle this together into a transaction across service bus, but unfortunately I don't have the time to explain all the details of that one. With topics, as I said in the beginning, multiple outs. So you can now do message distribution, and you can send one message to all the subscribers. Or you can do constraint distribution, where the subscriber now selects which message they want, and you can do that for partitioning, you can do that for routing, you can do that for all kinds of reasons. I'm also going to get to that a little bit more. Correlation is something that you use if you are doing request-reply patterns over service bus, which you can do. All the queues and the topics are obviously one way, but what you can do is you can go and set up a send queue that sends to a backend system, and then you can set up a reply queue, how the backend system sends data back. The latency here on the server matters. The server latency is about 7 milliseconds, end-to-end, tested, durable latency. On service, it's a little slower because of all the mechanics inside of Windows Azure, between 70 and 30 milliseconds. Still, both of those numbers are typically good enough that if you are taking someone's credit card and are posting that for processing and you want to get a result back, that's a good path to do that. It's much better than doing that volatile. So you can send the message in for processing. The processing happens at the other end. Now, if the client goes away, disconnects, or you still have the message, you send it back to the front end. The front end doesn't go and pick it up. Then it lands into, let's say, a dead letter queue. From there, you can go and inspect where it goes, also with a program. You never lose track of what that processing chain is, which is especially important in commerce scenario. So you can go and do also this from an ASP.NET front end. You have multiple senders, multiple logical threads, and the logical threads send to a backend. Then you can have load balancing, as I just explained, on the back. So you can have multiple receivers, which then go and post into the reply queue on that particular machine, or use sessions to demultiplex those things. Sending messages. Here showing the .NET SDK. The other SDKs are very similar. You have a queue client that we create from a connection string that looks like SQL. You can get that from the portal. And then you effectively send a new brokered message where I here go and set the label. In the lower part, I create explicitly a new brokered message and also set one of those custom properties here. What we see very many customers do is not use the body of the message at all, but rather just use key value pairs in those messages, which is actually a very nice way to take simple structured data and post that and send that along. If you don't really have very complicated data, it's not a bad idea to just use key value pairs and forget about all that schema and all that other complication. This is even easier than JSON, right? A side. In HTTP, this works as well, so I can go and send the message to Service Bus on the right place using a post where I simply go and set HTTP headers, right? Purchase order ID, :1, 2, 3. Turns out the HTTP client has a parser built in. You don't even need JSON. JSON's way too heavyweight. And I'm not even joking. Receiving messages. Similar model, two ways. You have a receive and delete option that you set. On the REST protocol, if you were doing that directly, you would be issuing a delete, which basically immediately takes the message at the top of the queue and takes that out and returns that to you. Here you do that in the SDK. You receive the message. If you were supplying a timeout to receive, we would return a null once that timeout expires and we don't have a message for you, because that's expected. You're actually asking us to do that. It's a clean exit, and we don't want to go and throw exceptions and make stack traces, etc., just because you couldn't get a message in that time. So you might get a null out of that. Peak lock. You set that receive mode, then you receive, and then you must go and complete that message, because otherwise it's going to pop up again after the lock expires. Abandon, once you are seeing an exception, is a nice thing to do, because it releases the lock before you then go and throw back into your own thing. If the max delivery count on the queue or on the subscription that you can set determines when that message is, how long that message is presented to you. So if you crash 10 times, that's the default, right? At that point, we put that message aside in what we call a dead letter queue, which is on the side of every queue that you can use like a normal queue, except that the only way that you can get messages into it is by calling dead letter from here or moving them with a HTTP gesture. On the topics, as you create a subscription durably, you can go and create these filters. These filters are based on SQL. So you create in Service Bus, you go and create a queue, or you create a topic. On that topic, you create a subscription. As you create the subscription, you can supply that filter. That's the entirety of the language that we have. So we have implicit conversion of types as we need them. We can go and compare things. We have logic operators. We have set operators. We have like matching as in SQL. And we can go and also do some simple math. For instance, we can do a mod, which is kind of interesting. If you do, for instance, partitioning, if you partition spaces, and you can go and apply those filter conditions. You can make rules. Each rule consists of a filter condition and an action. I'm going to get to those in a second. And you can have up to 2,000 of those rules on a single subscription. So if you simply want to get all the messages that have a particular correlation ID, a particular customer ID, whatever they are, you can add those rules. You can actually also add those transactionally. The subscription actions are paired with that, and they allow you to actually edit the message. So you can select the message out based on some criterion, and now you can go and edit the property. So you can set a property to a new value, you can remove a property, and you can go some simple expressions here, say first name plus space plus last name. You can go and do some simple editing operations on this. There are no functions beyond new ID, but you can go and as you flow messages, you can go and assign new IDs, you can create new sessions, you can do all kinds of interesting things on the fly with that logic. This composes perfectly well with my favorite feature, auto-forwarding. Auto-forwarding, and this is why I'm making a little bit room in this talk. There's a number of sessions fell on the way because I really want to dive into that a little bit. Auto-forwarding allows you to go and chain queues and topics and do scale out and some other tricks and look at the way how this is happening. So I have two queue descriptions. This is how you create a queue. You say new queue description, and then on the namespace manager here, what you say is create queue with that description. And if you want to go and create a forwarder, you say on the source queue here on that description, you say, please forward into the entity with this name, within this namespace. Now we're configuring the source queue, my Q1, to no longer allow you to pull data out, or you don't have to pull data out, but instead all the data that goes in gets forwarded into that second queue automatically. You can do the exact same thing for subscriptions. So now you get store and forward capabilities within entities inside a service bus. This currently interoperates with queues and topics, and will also work with notification hubs. Now you'll say, how would that make sense with two queues? Bear with me. Example number one is right on here. So you have a queue, and that queue forwards to a topic. You'll say, why? I tell that queue, I give the name of that queue to some client and say, you post your messages here. What I can do now with this forwarding mechanism, I can go and actually edit the rules and say, everything that comes into this queue from this particular client, that's the gateway for that client, no longer goes into that topic, but actually goes into that topic. And now have a redirection mechanism in Service Bus, how I can go and assign fixed ingress points to external clients, and I can go and rewire them as I need them inside the system at runtime. So that is an enormously useful thing. So you can go and effectively go and retarget things inside a service bus by leaving people with fixed addresses. So that abstraction helps you already. Where it gets even more interesting is when you think about fan out. You saw the numbers, those were for the server. They were not for the service. The numbers for the service are lower, right? I'm going to give you numbers that are not, I'm just going to give you a sniff. So for the service, you can expect about 2,000 messages per second on a queue, 1,500 messages per second on the topic, for 1K on a good day. On a super good day, you can actually get higher speed, but that's kind of what you should think about in terms of throughput. And that's still, if you calculate this out to megabits per second, it's actually not so shabby either. But these are limits, right? Because there's physics involved, and we need to go and manage a particular queue, particular entity, and we need to go and stamp the numbers on them, and et cetera, et cetera. So there are physical limits for how much throughput we can get. If you need more, you can go and achieve that using the forwarding feature. So you can go and make a topic with 3 subscriptions. Now you're taking that throughput of that topic, 1,500 messages per second, and effectively dividing that by 3. Now you get a flow rate of 500 messages per second per subscription. What you now do is you forward into more topics. And each of them has its own capacity limit, but that's kind of still around the same number, 1,500 messages per second just about. So you can actually sustain that flow rate through that entire tree. You go and create topics, and you create a further set of topics, and you go and wire them all up into this tree structure. And with that, you can get a fairly high sustained flow rate for a huge number of copies that you're creating. Right? We're creating at the edge here right? We're creating, what's that, really threes? We're creating a bunch of copies. What you can also do with that tree is targeting, because you have these rules. So you can say, I want to send a message in here, but I really only want to send that to one device, but I don't know where that device sits. So you send a message into that tree. The message actually gets flooded through that entire tree and then shows up at that one subscription where that one device sits. You could go and narrow this down also by putting those devices in groups, and then kind of narrow down where this flows by also having rules on these intermediary subscriptions. If I wanted to send a message to all the devices that I'm on, right? So I have a Windows Phone app, and I have a Windows 8 app, and as soon as they open, I want to see the same notification, the same information in both. I can also send to the user ID. And so this all depends on how you set your properties in the inbound messages, and then they land in the right buckets effectively, and you can go and make the scale really, really large. The opposite of that, so this is one example of how you can use that auto forwarding. Obviously, there's a lot of more combinations you can use here. The other one also has to do with scalability, since we're talking about building scalable and large systems, is fan-in trees. So if you have extreme bursts of traffic that you're getting, as I said, 2,000 messages per second is a good number to expect. Half that maybe if you do capacity planning for a bad day, so let's say 1,000 messages per second. Ingress for a queue. And now you have many clients, your entire population of point-of-sale systems, and you are a huge national retail store, fast food chain, whatever you are. And every hour on the clock, they send you stats, which means now you have a flood of data which comes in at that moment, and then it's quiet for the rest of the hour. How do you deal with those extreme bursts? You need to have effectively, for a short period of time, reliable throughput and reliable messaging throughput for hundreds of thousands of messages per second. But ultimately, you want to go and process that later. You can do a fan-out thing like this. So you pin those clients to ingress queues, and you wire those ingress queues to concentrator queues in probably multiple stages. What will then happen, all the messages are kind of running into those gateways, these ingress queues, and are then getting trickled down into the concentrator queue, so you have one place to actually get them from, if you want to do it that way. So the forwarding feature helps you with that, and also helps you with building. So the fan-out thing helps you with dealing with super large client populations at very high flow rates. This one helps you with super huge client populations for ingress as well. And obviously, you can also hook a topic at the end. Also, another combination is getting interesting with notifications, because notifications have a similar model, actually have the exact same message model as we have for the message entities. One thing I want to get to, though, before I get to the notifications, is that the binary protocols that we have actually matter significantly, because there's a lot of HTTP in the world in messaging, and I've seen a company they said, well, we're going to move to HTTP completely, blah, 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 we don't believe in binary protocols. The point is, we can service, because of the nature of HTTP, we can go and service one entity per request, per socket, concurrently, and one pending operation, one receive or one send, and we need to give you that 60-second timeout. On SBMP and also on the new AMQP protocol, we make one socket, and you can target any number of entities with that one socket, and you can have any number of pending requests, pending operations on that one socket, and there's no fixed operation timeout because we have a ping that's completely independent from the operations, which we can't do with HTTP, because there's nothing we can do on that socket to kind of remind the infrastructure on HTTP. So I would love to do a longer polling poll than that, but I can't. So the binary protocol family, what we're also going to add there, and that's something that we do in the standards body, is to put AMQP on top of WebSockets. So then we have a protocol, a socket that we can go and establish through HTTP infrastructure, but WebSocket still means you need to have something that you run over that as a real protocol, and so we want to run AMQP on top of that. And there's also some other options for running WebSockets and some other things I'm going to get to actually right now. SignalR, very popular, very young, still very popular signaling library for web clients, built in the ASP.NET team. Two enterprising gentlemen started this on their own time. Now it has become a real thing. And what that does is effectively it allows you to send events out to very many web clients at the same time. Very easy, super easy. So that's also a pub/sub model, right? You publish, subscribe messages, and they're super lightweight, and they're kind of doing that over the web. So how does that compose? I have pub/sub, that is pub/sub. How does that compose? Well, it's actually composing very nicely. The way SignalR works is you have all these long polling WebSockets, server-side events, forever frame sockets into connections into the browser, and they're listening. And if they want to send a message to everybody else who's listening, they send the message to the bus, they post it, and they post a key value pair effectively. And then you have filters defined from the clients, which then go and filter out the data that comes out of SignalR. So it's a very lightweight pub/sub system. And it's super fast, and it can do 10,000 connections on a machine that's beefy enough or even more. So it's awesome for the web. You can build wonderful things with it. Games, you can build score tables, you can build stock tickers, you can build all kinds of things that we've seen, which are really make your web pages come alive. It's also very suitable for Windows 8 store apps, for instance. That and what I talked about before is actually not in conflict at all, because SignalR's scale-out story is Service Bus. So we actually built for SignalR a backplane for how SignalR nodes, individual machines, can actually go and synchronize their state, can synchronize all those messages, and that happens through Service Bus. And you'll also eventually be able to send messages to a Service Bus through a SignalR farm from Service Bus. So if I have let's say I was doing a website where you can monitor a sports event, and you can go and see live, let's say, racing timing as it happens. We will be able to go and feed that data from a topic, from the bottom kind of, and disseminate that then through SignalR. Socket Node.js, Socket.io, very similar to SignalR in spirit. And we're working with those guys too, and we have a team that writes Node. Their model for scale-out is exactly like this. We have or at least the one that we provide, is we're making a scale-out on top of Service Bus for Socket.io that works effectively in the same way as that for SignalR. So you can go and effectively scale out these really what are really on node infrastructures. You can scale them out using Service Bus. Which gets me to notification hubs. SignalR, Socket.io, and effectively topics also, if you hook them up to the client, are in-app notifications while the application is alive. However, many of the notifications that we get, if you have an iPhone, or if you have a Windows phone, or if you have an Android phone, if you have any of those phones, are coming at unexpected times, not when you have the app open, right? Yesterday, my timeline or my iPad was flooded, and also the surfaces were flooded with information that the Venezuelan prime minister or president died, and at that hour, and so I had none of those apps open. So these push notifications are there to engage, so that I engage with that app. So I pushed on one of those things and got into the AP app and read about it. Notification hubs are for that particular channel. SignalR, Socket.io, and topics are for when the application is alive and can talk. When the application is not alive, we need to have a channel. And notification hubs are aiming to take these diverse notification channels and make them the same. So, brand new feature is in preview in Service Bus today. There are 3 videos about it on my subscribe blog, which go into detail and actually walk through the iOS experience and the Windows 8 experience. What they aim at is increase application engagement. So you notify the user of some event. You have these, all of you are using Windows 8? Yes. Either you use it because you want to, or you use it because you have to, because you're pros. But anyways, you all know about these live tiles. The way the live tiles come to life is through that push notification system. That is how you make your application say something while the application is alive. The only way you can do this is to make it alive through these push notifications or a background process, but there's not a lot of applications that get that privilege. So you can update a tile from the Windows Store app with current information, financials, weather, whatever you have information you need to tell people. If you're writing CRM, a new lead, whatever that is. Or you can go and do something urgent and pop a toast, or pop an alert in iOS, or pop a toast or an alert in Android. On all those things, there's a platform-specific service. There's one precious socket that's being maintained. And that's true for all the devices that you may have in your pocket today, if they're smartphones. They maintain a single, one precious TCP socket to the home, the platform vendor, at any time when you have the phone turned on. That socket is maintained on low gain, right, with a very long NAT ping, 20 minutes, 30 minutes, so that the phone can preserve battery. You can't do that because you would burn the battery. So there's one of those sockets. And that socket is controlled by the OS shell. And that's the same thing in iOS, as in Android, as in Windows Phone, as in BlackBerry. All the platforms are doing exactly the same strategy. One socket that's being maintained, and that the application needs to send through. So you need to deliver a message to the push notification system of the platform vendor that then gets routed to the shell, and then the shell goes and pops the notification. And there you get a link to your app. So your app usually doesn't see any of that. So if you were doing an end-to-end solution, if you want to build push notifications for iOS all yourself, you have to deal with a lot of code. Because if you have a million apps out in the field, or 2 million, each of those comes to you and registers, so you can go and send it messages. So you have to deal with 2 million individual registrations. And if you allow targeted selected messaging, you now have a thing where you need to go and deal with all that targeting. So you're building something complicated. So having a very successful, super successful mobile app with push notifications makes you build a service that can deal with however many clients you have. You must build a super scalable backend for it. You're kind of forced to. So the way this usually works is you register as the client application launches. It registers with the platform notification service and then tells the application backend, something that you host on the internet. And so you give it that channel URI so that the application can then, when it has something for you, go to the platform notification service with that handle to tell you. There's also maintenance required. Like those handles expire, and so every time the application starts, it actually is required to go and inquire whether it changed, its ID changed. If that changed, it will come to you and replace the one that it has. So that's protocol you need to implement yourself too. So whenever someone opens that app and you have 10 million copies of that app out, well, then you're building an infrastructure for 10 million apps, not only once, but actually every time those things start. So you're in for quite a bit of infrastructure that you need to go and build. That actually doesn't get better with most of the infrastructures, the competition, if you will, that provides you with push notification services, because they still make you maintain those handles. They make it easier to send to multiple, and they don't require that you implement Apple's native TCP protocol, but they make it easy to do that via HTTP, but they don't relieve any of that burden. So challenges, first of all, is platform dependent. If you want to target, if you have apps that run on 4 platforms, you have 4 completely independent systems that go and need to maintain that code. Routing is if you target at users, now you need to go and target at users across those different platforms, so you need to unify those things in some way. And then obviously scale, because if you have to store and deal with these millions of subscriptions, and you need to maintain them and individually delete them, that's kind of hard. That's hard. So the reason why you don't see more of these push notifications enabled for more apps, and only tend to see the super large companies, the super large media companies use them at scale, is because it's hard. It's hard in that way. People who know how to build super scalable systems tend to implement them. Others tend to not implement them, and they're really hard to implement if you don't have a server set up. If you really or if you don't have a public server, if you just have enterprise services, internal enterprise services. So the notification hubs are different. You create a notification hub as you create a queue, or as you create a topic, or as you create a relay. And then the iOS app and the Windows Store app still goes to APNS or WNS, and we're going to have Android support before we ship. And then goes to the notification hub. We deal with all that for you. We deal with registration, we deal with non-deliveries, we deal with any of those things. You can hook up to, and this is the current goal that we have, it's not a quota yet, 5 million of those registrations concurrently on one of those things. Which also means that you can now send a message, a notification, from your application backend, not directly to those servers, but actually to us, and we're going to go and spread that out. Not only can we do that for an individual target, but we can actually go and deliver one message to all 5 million. So we also have a super scale-out broadcast infrastructure, because we're PubSub, that will allow you to send that one message to 1 million customers in a very short period of time. I can't give you a number yet, but the goal that we have is that we can go as fast as the quotas of the infrastructure vendors permit. So as much of an allocation as you get from Apple or as you get from Windows for how many messages you can push concurrently to your app, we'll be able to actually make good on that. So if you can send 100,000 messages per minute, we can go and send 100,000 messages per minute easy for you and then for everybody else too. So you send one message in, and we send that to everybody who's interested in that particular theme, topic, tag, because we have some other things here as well. You don't have to know a platform-specific protocol at all if you choose to, but you can use the platform-specific notifications if you wanted to. So you can still use Apple-specific notification and form it in your way. You don't have to store any of those device things. We give you broadcast to millions of devices with a single call. And then we also give you filtering using tags. So the tags is kind of an interest group. So now we have a tag for, you have a music app, you have a tag for the Beatles, and you have a tag for the Wailers. And you're only interested for those particular things. Or you're interested in soccer, and you're interested in Borussia Mönchengladbach, or you're interested in Borussia Mönchengladbach. For instance. I mean, what other club would anybody be interested in? So you have these tags that you can go and say, I'm interested in this. And now you're pushing a message in that is tagged with that tag, and it only goes to that particular interest group. So let's say you want to build a weather app. You could go and make a tag for your postal code, for your region, and for the country. And now I have weather alerts, which are either local or on the region or on the country. And based on those tags, I can actually target them at everybody individually. So tagging is something that is kind of in that system. So you can have 5 million registrations. Everybody can be interested in something else, and we will target the appropriate subset of them. You can have multiple interest groups, so you can have all kinds of combinations here. So we give you very easy PubSub with no rules you need to define, where you effectively just go and define the tags you're interested in. Much easier matching. And then another super cool feature, and that's something that's absolutely unique to Service Bus, is using templates. Effectively, mail merge. What you can do is you can make the client register the message that we shall send back. can be localized, can be a choice of message. So you can go and in Windows, for the shell, there are 27 or more different types of tile formats. You can now put the client in control of which tile it wants in which situation and for what. And you can actually partially fill them out with localized content. And just take the data and merge the data in. So not $message, but let's say $temperature Fahrenheit or $temperature Celsius. And you send a message in that contains both values, and you can basically just go and match that based on the user preference locally, but still distribute to 5 million at a time. So we're effectively doing a mail merge on the data that we send you. And it's completely in control. So in iOS, you can do the same thing. You can go and give us a native Apple notification message and just fill that out with these expressions that we have in that format. So this is how it natively looks in Apple. This is how it natively looks on Windows. And now all you do, as what you send to the application backend, is a simple message, key value pairs, and we're doing the mail merge on all those systems. Unique capability, completely platform independent push across all those platforms, and we're starting with the push notification infrastructures, and we're going to go and extend that to other third-party delivery channels as well. That's something that is unique. Nobody else has that, and certainly not at that scale. So, that is what I had. Kind of landed on time, 62 slides. Not too bad. That is what I had. What I would like you to invite to do is to actually go on my blog. And here you have the notification hubs, tags, and template concept. So I'll talk about that in more detail. I have a full walkthrough for the iOS edition, for the Windows 8 edition of how to go and set this up. Here's a conceptual talk with Elio. So there's plenty of material on this. There's something about SignalR. Here's how the Halo team, talking to the Halo team in the Halo headquarters and how to use those. So there's plenty of material on Service Bus, the messaging deep dive, a very short one of 2 hours. Plenty of material that kind of goes into depth on all the things that I've covered here, kind of introduce you to, and there's also some live coding there. And there were plenty of samples on the code gallery on MSDN. And with that, you have had a very long day. Thank you for staying. And I'll be, for about an hour or so, also at the Ask the Experts. Thank you.